Well, welcome back, and this is recording 1B in our series on the quadratic formula for Unit 4, Chapter 4 of Mathematics 2200. We're going to be using the quadratic formula to solve quadratic equations in this clip. The last clip we showed how to get the formula. Now we get a chance to see how it's used. As a reminder, here's the formula that we developed in our last clip. If we have a quadratic equation in the form, this is important, in the form ax squared plus bx plus c equals 0, the solution to that equation is negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's see how it's used to solve quadratic equations. We've got two examples. Well, one example, parts A and B, I guess. Solve each equation using the quadratic formula to express answers in both exact form and to the nearest hundredth where necessary. We have this equation 2x squared plus 7x plus 3 equals 0. First step here is to ensure the equation is written in the form ax squared plus bx plus c equals 0, which it already is. So it's just a step we have to check and follow if it's not already in the correct form. We identify the values of a, b, and c. So a is equal to 2, right here. B is equal to 7. And c is equal to 3. We substitute them into the formula. Our formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So we plug them in, and we have, in place of b, we have 7. So it's negative 7 plus or minus b squared, okay, the b is 7, minus 4 times 2 times 3. Make sure that square root's extended over everything that it's supposed to be. And that fraction line should be over all of 2a. So we have 2 times 2. All right, so that fraction line extends under everything here. Don't make it short, folks. You will find it will lead to areas of confusion sometimes if you don't do that. Okay, so we now do our calculations. Negative 7 plus or minus 7 squared, that's 49. Minus 4 times 2 is 8 times 3 is 24, all over 4. So bringing that over to a new slide, we now have x equals negative 7 plus or minus the square root of 25 all over 4. That's negative 7 plus or minus 5 all over 4. That gives us two cases. Just like we had with completing the square, negative 7 plus 5 over 4, that gives us negative 2 over 4, negative 2/4, which gives us, in turn, negative 1/2. In the second case, we will have x equals negative 12/4, which will give us x equals negative 3. And on to our next example, 5x squared minus 1 equals 7x. First step, make sure it's written in the form ax squared plus bx plus c equals 0. Well, it's not yet, so we'll have to bring that 7x over to the left side and make the whole thing equal 0. Identify the values of a, b, and c. Well, a equals 5, b now is negative 7, c is negative 1. Substitute those values into the formula. So our formula is, once again, negative b plus or minus b squared minus 4ac all over 2a. So we've got x equals negative of negative 7 plus or minus b squared, that's negative 7, but it's all being squared, and minus 4 times 5 times negative 1, all over 2 times our a value, which is 5. So the result there is we have negative of negative 7 is positive 7 plus or minus square root of negative 7 squared is 49. Now here, be very careful with your signs. Negative 4 times 5 is negative 20 times negative 1 actually gives us positive 20 all over 10. That place right there where I said be careful with the signs, that's a common place to make an error. So we've got x equals 7 plus or minus the square root of 69 all over 10. Let's take that to a next slide. So we have x equals 7 plus or minus the square root of 69 all over 10. Since we cannot simplify the square root of 69 any further, that's the best we can do. That's the exact form of the two cases. We'll just leave it as plus or minus and understand there are two cases, except for the fact that when we want the approximate form, we will have to separate the approximate form. And this is to the nearest hundredth. So our two cases are 7 plus root 69 over 10 and 7 minus root 69 over 10. So remembering, do the calculation in the numerator first, find the 7 plus the square root of 69 first, and then divide that by 10, and you should get 1.53. And in this second case, we get x is approximately, okay, notice I use the dot above my equal sign for approximately, negative decimal 1.3. So you can check to see if they approximately balance the original equation. Remember, we've rounded, so they won't be exact. And once again, in conclusion, to use the quadratic formula, make sure it's in the right form for the equation, identify the values of a, b, and c, substitute into the formula, and perform all necessary calculations and simplify.